We're going to play, just to warm up the crowd, a little three-question Hacker Jeopardy. We're just going to, just by a show, raise of hands. So for the first question, who invented the first prox card? Charles Walton and Tom Milheiser, Gary Carroll, or someone else? Raise your hand for A. Raise your hand for B. Raise your hand for C. Okay, that's pretty good. What security company dismissed it as a mere magician's trick? A, Wells Fargo. B, Securitas. C, ADT. Mixed crowd there. And what does this have to do with goldfish? The fish were used like canaries, the fish was using the logo of a security company, or the fish were in a fish tank with an underwater reader? A, B, C. Okay, well, we'll go through the presentation and we will look at the answers. Okay, well, the title of the talk, which I couldn't reveal until now, was Wiegand's Wonderful Wires. So maybe that gives you some clue. So I want to start off with a little bit of a disclaimer. I'm here as a private citizen and not representing my employer. All of the material presented in this presentation, with very, very few exceptions, has appeared in the public domain at some point. I will answer any historical questions about John Wiegand and the access control industry, but I will not answer any technical products about my company's products or any other manufacturer's products. And there's a lot of material to go through, so let's get going. So we have an agenda. We're going to talk about a card technology, the timeline, some old prox patents so we can set the context for what John Wiegand has done, a little bit of a biography on him, which is fascinating, some applications, some inventions that he made, Wiegand hacking. It's a hackers convention. How could you not talk about that? And what's next? So this slide here, and I'm going to be moving fast because there's a lot of material. This slide here is basically from a security magazine, and it's pretty good. I mean, it's not great, but basically it sort of shows you how all the card technologies evolved, both from a pedigree basis, where they came from, and on a timeline. And we're going to concentrate on the two that's highlighted in red, Wiegand and prox. So, who invented the first prox tag? Well, I did a lot of research on this after I found the patent by John, and basically this author maintains that it was a gentleman by the name of Mr. Cardullo, who actually had a conversation sitting next to an IBM employee, and then he filed a patent. And sure enough, the patent did issue. It's been issued in January of 1973. Remember that date. And here is his patent. And I'm going to be talking about priority dates. I sort of play in the IP space now. That's my new role, patents and trademarks. And basically a priority date is the earliest date of a patent that you actually have some legal enforcement rights. Don't confuse that with the invention date. In everywhere but the U.S., it's first to file. In the U.S., it's first to invent as of now, unless they change the patent system. So watch these dates. Well, first of all, there were, if we want to disprove what this author has claimed, there were many, many earlier prox patents, and I've outlined one of them right here. However, all of these prox patents basically used an analog system, actually, and later on systems were developed like that. There was a company called Schlage who actually used tuned elements to actually resonate at different frequencies. But none of these earlier patents used digital memory and actually sent a unique card number. And by the way, Cardullo's first prototype actually could store 16 bits, and they were actually using core memory. Wow. And here is his patent. Okay? And you'll notice May of 1965. So now we're going to introduce John Wiegand, who was a musician with perfect pitch. And he actually came over to the U.S., as we'll see in his biography, to be a musician. But history will never remember him for that. They'll remember him for the Wiegand effect, which still is very predominantly used in access control today. And in doing the research, and I'll sort of tell you later how I came about and why I'm doing this, I found this patent. I got really excited. And sure enough, this patent actually predates all the prox patents, at least on a digital basis. And to quote one of my favorite radio personalities who's not with us, Paul Harvey, now the rest of the story. So his patent he called the Interceptor Transformer Prox Key. And his priority date is December of 1965. And what he did was he actually, well, before we get to that, let's talk about what's in his patent. So some of the applications he said is, a person can carry a prox key in his pocket to unlock doors automatically. The invention can be used in a bank, defense manufacturing, where various persons have authorized access to only certain parts of the installation. It could be used by tenants of a building. And the invention can be used for opening garage doors automatically. Why was he so specific about garage doors? Actually, that was his first patent. He actually has 2 patents on garage door openers. So if you look at these applications that he's talking about here, this is what we do with prox and contactless smart cards and all kinds of electronic physical access devices now. So what he did was he used his Wiegand wire. Of course, it wasn't called Wiegand wire until later. He would wrap it around a coil, a base core, and then sort of spiral it and then actually laminate it or put it between 2 pieces of plastic. It turns out that he actually studied at Bell Labs and he learned about bubble memory, at least the early research. And he actually instituted a form of bubble memory using Wiegand wire. Fascinating. And if we look at some of the drawings here, you'll see that, I don't know, let's see, does this pointer show? You actually have these coils here, and he's showing, some of the pulses there in his circuit. And basically, it was a classical prox system. It used near field, which is the phenomenon that actually powers up traditional prox and actually contactless smart cards today. And he stored bits, and it was actually read-write, believe it or not. And here's a little picture. Again, the patent. I encourage you guys to check out the patents. It's fascinating reading. You can see the data going up and down, and he's writing data and clocking data out, and then he can actually match IDs. So now that you know that John invented the prox card, he basically, with his partner Milt Valensky, went to a company and showed it to them. So I want you to keep this quote in mind when I show you the next slide. Basically, Arthur Clarke said, "Any sufficiently advanced technology is indistinguishable from magic." Just ask David Copperfield that. So Milton Valensky was John's business partner, and that's an actual really interesting story in itself. It's almost like a Harvard business case study. You have this very prolific inventor who's a genius, John, who's really going to go nowhere because when we all develop products, you learn that you can have the best product in the world, but marketing is really what sells. So he demoed John's invention to ADT. And they actually dismissed it and thought it was a magician's trick. Too bad, because it ended up that was the end of the invention. I don't know if it was shown any other places, but basically this has never appeared anywhere. And actually I've looked and not seen anyone adopt any of it. So it was never commercialized, yet it was far ahead of its time. I mean, you're talking about read-write. And as I said, it used the same principles of prox today, and it was ahead of Cardullo's invention because Cardullo was actually using core memory, and core memory, although is you got these little ferrite donuts. John's wire actually, if you spiraled it that way and sort of like that braid that he showed, the data density was far, far higher. I mean, I've seen some writings in his own inventor's notebook where he stored, 50, 60, 100 bits. And by the way, the frequency, 4.8 kilohertz. An interesting feature about frequency, except for UHF, because that works with a different phenomenon, that actually works with far field. Today's prox uses something called near field, which is basically like a transformer, it's air core transformers. And the lower the frequency, the further you can actually operate. That's why the government uses communications from submarines at like half a kilohertz, and they can go hundreds of miles. So it was passive, and it drew power from the interrogator. By the way, when you read patents, interrogator is the buzzword or the commonly used name for a reader. Okay, so when you see interrogator, we're talking about the reader. And it could actually use a battery, so you can get longer communications. That's all revealed in this patent. So let's move on. Who was this man, John Wiegand, and why am I even talking about him? Well, he was actually neither an engineer nor a physicist, but he was a musician. And he was born in Germany, and he came across to the U.S. to study piano. And he actually got a scholarship to study with a famous composer and conductor here in the U.S. And I put the word piano in red for a reason, because what do pianos use to make music? Wire. And I believe, and I'm trying to confirm this because I've been meeting with some of the people that that knew him. And I believe that he got his inspiration for the Wiegand wire from piano wire. And I'm told he actually tried to use piano wire in the beginning. So going on with his biography, he attended Juilliard in New York, and he became interested in audio amplifiers. And then he worked in Bell Labs. And when he worked at Bell Labs, he actually made friends and with some of the famous early pioneers at Bell Labs in various materials research. And then he went to work for Sperry Gyroscope, and then he went to work as a government contractor building tape recorders. By the way, these early tape recorders, what do you think they used? They didn't use magnetic tape like we know it today. They actually used wire. Okay, the early tape recorders actually used a wire. And again, you're seeing how all these coincidences, piano wire, tape recorders using wire, how he became fascinated with wire. So in 1965, he joined with Milt Volensky. And actually, before he actually could afford an oscilloscope, remember, this was a tool and die maker who came from Germany, just came across the boat on a scholarship. He'd actually listened to the wire through a loudspeaker, and he could rate the quality of his Wiegand wire by the pitch and the sound that it made. And remember, he had perfect pitch. So again, another interesting coincidence. So later they met, Milt Volensky and him, and John did the inventing and Milt did the promoting and selling. So let's talk about some of John's inventions. So from Sensor Engineering, which was the company that first came Eklund, then Sensor, they listed a whole bunch of inventions. And when I met with Milt Volensky recently, who's still alive, and actually he's trying to sell me John's notebooks because he thinks there's thousands of inventions in there, and we can make a lot of money. The number of applications are huge, and they're in planes, trains, and automobiles. I mean, they're used in anti-lock brakes. They're probably in your car, Wiegand wire. So the list goes on and on. So in 1970, he filed his patent for the Wiegand card, and there's the patent. And interesting enough, he said, well, we could use it as a passport, and we could use it in other places where the code can't be changed. And back at that time, it was fairly secure. I would not say it's secure as some other technologies, but everything has a place, and you always evaluate the level of security with the risk that you faced and the cost of what you want to do. And he actually talks about using it in credit cards. Could you believe that? And then in 1970, which was about the same time, he actually filed the patent for the Wiegand card reader. And look at the drawings. It was actually a drop-through reader. And this, by the way, is not actually what the Wiegand reader became, that those of us in the industry know. This uses wires that are longer and shorter in the middle. And there's a picture of the reader, and it was a drop-through reader. You would actually drop the card and it would pass through. And this is a picture of the unit that Milt Volinsky actually made sales calls on the New York City Transit Authority. Now, I haven't told you, but I've been in this industry a long time, and I actually went on that sales call with Milt Volinsky. And I actually met John Wiegand in his lab in Valley Stream, so I have a lot of personal connections. By the way, the card, it was not called Wiegand at the beginning. It was called SNMW. Can you see it on the card there? You it's probably not as big as it could be. And SNMW stood for Self-Nucleating Magnetic Wire. Boy, that would have never sold. SNMW? We all know it as Wiegand cards. So now let's talk about patents. I told you I'm in the IP space, and patents, there's, as part of the research I'm doing, there's thousands of patents all referencing Wiegand, and the applications are all over the place, and they're still being filed. So let's take a look at some of them. Well, here's one for a Wiegand token, similar to what you'd use maybe for Chuck E. Cheese, so that you couldn't counterfeit the token. This patent, by the way, is owned by my employer, and actually, since this is not an application we're in, if anybody is interested in buying the patent, we could talk about that. We also have some other Wiegand patents, but we're not practicing this patent, obviously. Here's another one. I'm starting out with the applications in our space. Here's one that's actually used in a combination lock, and the Wiegand wire can actually generate electricity. So as you turn the dial, it would actually generate pulses and actually power the lock. Here's one we use the Wiegand wire because it's very good for position sensing. It was actually used in the auto industry a lot for distributor caps and angular positioning and anti-lock brakes. Here's one that actually uses, as the wires go by left or right, to count the pulses. And by the way, it would probably be pretty hard to defeat it with a magnet if you know the Wiegand effect. Here's an old patent. I bring it out only because look who the assignee is. By the way, assignee in the patent world is who's the owner of the patent. Well, it's the United States of America, which was filed by the Department of Energy. They thought that this technology had very, very interesting applications, and they actually filed their own patent. The U.S. government. Here's one for a Wiegand key. Okay. Here's one filed by IBM. Identification tags using amorphous wire, Wiegand wire. There actually was used in CDs. Actually, they'd put them in CDs so you could actually also verify, do some digital rights management in the old days. Again, look at the dates of these. You're talking pretty old time. One of the most interesting applications for the Wiegand effect is generating of electricity. And it actually has significant advantages to generate electricity versus traditional techniques. And it's actually used a lot in energy harvesting. And here's a patent for it. And actually the Wiegand generator is generating electricity to power a transponder, so you can actually use radio waves, so you can have a self-powered transponder. Again, you don't need any commutators as you would in a regular generator, so it's and it works over extreme temperature ranges. For those who don't speak French, a bicycle lumiere is a headlight for a bicycle. So we're generating energy to power a bicycle headlight. Here's one using energy inside a pacemaker. Okay? And this is a pretty late patent. Actually, it's not a patent yet. It's actually an application. But it's very recent. It just published in 2009, in January. And it'll be on its way to making a patent. Using the Wiegand effect in a pacemaker. So maybe John Wiegand will save someone's life. So let's talk about the Wiegand protocol, because that's the outgrowth of what actually you could argue almost was just as famous. So the Wiegand protocol actually, how it came about is you had these wires, as you could see in the picture there, and would go past a reed head, and it would generate these pulses. You notice, by the way, some are up, some are down. Those are ones, those are zeros. And card key in the early readers, by the way, only used a single wire for the Wiegand protocol. It was called the one-wire interface. It would actually look just like that. Ups are ones, downs are zeros. Nowadays, the Wiegand protocol uses two wires, data 0 and data 1. So you get those pulses. It would go into a little buffer circuitry, and out would come your pulses that is now used in today's Wiegand protocol. And as everyone knows, the Wiegand protocol is used in a lot of access control equipment, yet it is not using Wiegand wire. Smart card systems, biometric systems, prox systems, they've actually used this standard, which became a de facto standard because it was so interoperable and everyone adopted it. Funny thing about standards, usually standards come about because everyone's using it, and it becomes a de facto standard, and that's how the Wiegand protocol became a de facto standard. So this is a hackers convention, and obviously it would be remiss if I didn't mention some of the hacks that's occurred. So actually in 1992, Bill Payne, who I just spoke to recently, he was an employee of Sandia Labs, and Sandia does this high-tech, kind of research. And he was actually asked by the FBI to figure out how to crack Wiegand cards. And he found a way to do it using MagnaView film and a cow magnet. And by the way, the code strip that's on top, Wiegand cards are made in two different ways. Card key actually would put a continuous strip of wire in a card and use a key punch to actually punch out the portion that's not being used. Sensor engineering went on to do it in a completely different way, completely computer-controlled, automated. But Card Key was a licensee, IBM was a licensee. There was many, many licensees of the Wiegand effect. Anyway, he found a way to expose the wires and so to speak, clone cards, and he actually published it. Unfortunately, the FBI didn't like that very much, and he claims that it was not classified because the research wasn't put in the candy stripe wrapper. I'm sure there's some people in this room who knows what that is. And he was actually fired, and he's still trying to clear his name. So, and at DEFCON 13, Zamboni described the theoretical attack, which he called Wiegand injection. And then recently at DEFCON 15, Zach actually demonstrated a replay device, which he called Gecko. So let me give a little wrap up here. Basically, I'm doing this since I've been in this industry. I probably don't look as old as I am, but I've been in this industry since 1978, and that's my livelihood, and it's been good to me, and I'm trying to pay homage to John Wiegand, who I really think was the foundation of the physical access, at least from electronic point of view, control industry. When I first got involved with sensor, I actually was working on PDP-11s, and I remember when the Wiegand reader came out, people would actually buy Wiegand readers, hook them up to TRS-80s, and call themselves an access control company. And I can remember at a trade show using a Wiegand reader as a hammer because I needed to hammer something, and of course it was indestructible. And because of this very reliable, robust, fairly secure card that came out, I believe the electronic access control industry was launched before that. Sure, we had MagStripe cards, but MagStripe wasn't really well suited for the access control industry. It wasn't as robust, and it suffered from being demagnetized. And I actually, as I said, had the privilege of meeting John. So I'm actually going to write a book about him, and I've been doing research, meeting people. I found his engineering notebooks, and I've been going through them, and it's fascinating. So stay tuned. I will post everything when I get to it at www.wiegand-effect.com. Oops, I forgot the .com. And actually a colleague of mine, Dr. Scott Guthrie, when I was going through some stuff that was going to be thrown out. We found this stuff. He said we should write a book on him. I have no timetable for completion. I have gigabytes of data. I mean, it's just unbelievable. And maybe at DEFCON next year, if I'm allowed to speak, I can actually show you some of his original equipment and show you what led to it and the Barkhausen effect and how the Wiegand effect works and how you can actually listen to little magnetic domains flying around. That's called the Barkhausen noise. So that's it. So I will be available for questions in the speaker room, but subject to the caveats that I said, that I'm really here to talk about John and the access control industry. So thank you.